Okay, so today we're going to be going over a really old piece of crap, the A1297 MacBook Pro from 2009. There are many things that make this a piece of crap. The first thing that makes this a piece of crap is the fact that it's from 2009. It has a Core 2 Duo, and it not only has one graphics chip, it has two graphics chips. So what's the only thing that's worse than a portable Apple product that has one discrete graphics chip? A portable Apple product that has two discrete graphics chips. Because if you've been watching this channel for any period of time, then you're aware that for almost every single year for the past 10 years, there's been an extended warranty program released because of a fucked up graphics chip on an Apple motherboard. Ironically, this one actually isn't that bad. The small graphics chip is a piece of crap. The small one is a piece of crap. It does have issues with failing. The main issue is actually with some muxing firmware between this one and this one. So you'll see flickering on the screen, but they fixed that in some type of VFI update, I think, a few years into it. And the main chip on here, the main graphics chip on this one, is actually pretty decent. It's not very powerful, which is good, because so it doesn't die like all the other overpowered ones do. So let's get started on troubleshooting this board. This board doesn't want to turn on. It has power on the battery, but doesn't turn on. So I'm going to go over one of the main flaws with this machine and one of the main things that keeps it from turning on. So as with all no power issues, the first thing that we have to do here, actually the first thing I have to do before, what was I just, first thing I have to do is find my tweezers. I almost lost my good set of tweezers. I can't let that happen. The first thing that you have to do is go through the list of power rails. It's the first thing that I do when I have a no power issue, so that I can try to figure out which rails are missing and then go from there so I know where to look. Because again, this is a big board. There's a lot of stuff on this board. I don't want to test every single component. That is a complete and utter waste of time. A lot of people getting into this ask, how do you measure the individual components? How do I check every component on the board? Or they'll ask me questions on measuring specific things, and this is really about narrowing down what could be wrong. Where do you think the problem lies? Narrowing it down to a specific section. That's more important to me than checking every component on the board. So as long as people are asking questions about that, I feel like it's worth discussing and it's worth bringing up. Because if you are in that mentality of let's check every component on the board, then you're in that mentality of wasting a lot of time. So first thing to do here is bring up the schematic. All right, so we're going to go over to the page of the schematic that has power rails. So we're going to go over to page 6. And by page 6, I mean page 7. And by page 7, I mean page 8. I used to have a memory. That was a long time ago. So the first thing that we check here is PP bus G3 hot. And it says 6 volts, but we know that that's bullshit. I know that that's bullshit because I've measured this before on working machines, and it's not that amount. So if I measure PP bus G3 hot, I get 8.37. It's supposed to be 8.4. That is close enough. And again, the Apple schematic is just bullshit there. So now we're going to go back to page 7. And now, when it comes to rails like this, PP DCN, I already know the DCN rail is present. It has to be present because I already have this. I already have the PP bus G3 hot rail. I wouldn't have the PP bus G3 hot rail if PP DCN was not present, so common sense tells me that's there. PP3V42. Let's check PP3V42 next. So we open my board view software. Let's open the file for this. PP3V42 underscore G3 hot. All right. And on this one. Hello. So I go here, and now you can't see it. All right. I go here, and what do I get? I'm supposed to get PP3V42, and because I'm measuring in the wrong place, I get PP3V4 nothing. All right, let's try to measure in the right place. That's fine, though. The board view is upside down, as it always is. Ow, that's loud. Ow, that's loud. Fuck. Oh. Yeah. 3.4 is there. So now we move on to the next. PP5VS3. The next one on the list is going to be PP5VS3 underscore reg. Wrong board view software. Still wrong board view software. Interesting. PP5VS3 reg. I should see it on this capacitor over here. All right. PP5VS3 is missing. So now what I'm going to do is I'm going to check for a short to ground. So I know I have no voltage there. Now I want to see if there's a short to ground. Now with my methodology, what I like to do is check the beginning and the end of a circuit. So now I've checked the end of it, and the end of it has no short to ground and no power. So now I can check the beginning of it. The reason I do that is because I don't want to waste time on a lot of things that are inconsequential. PP5VS3. So let's see, where do you come from? Here we go. This is a buck converter. Now, I've been over this so many times before. Many times before. PP5VS3 comes out at the end. And if you don't know what a buck converter is, you should read my earlier posts on what a buck converter is. So we're going to go over here and see that EN1 is on this side. Enable, that's going to turn it on. So we go over to EN1, and we see that it's... Are you fucking kidding me, Apple? What is this? What is this little box? Look, it's a little box that it drew to itself. Look. Look, it's touching itself. Jesus Christ, what the fuck is wrong with Apple? Every schematic from 2008 and 2009 sucks. I went over this in my video on the 820-2530 just a week ago. What is this shit? What is this little fucking box? What is it? It's like fucking Pee Wee Herman from the early 90s wrote this schematic. Look at it. Goes in a little loop and just touches itself. Okay, I'm just going to assume that this is where it's coming from. And this is going to confuse people who are trying to learn these schematics, you know, just kind of get a general overview on these schematics for the first time. It's going to confuse them a lot. Because they're not, you know, I know that that's probably what that signal is for. I'm just drawing a line in my head, but it's kind of hard if you're a newbie to really follow that, and that sucks. So, yeah, but that's Apple. So that's going to come from here. PM Sleep S4L is going to come from the MCP79. So now let's check PM Sleep S4L. That's not a PM Sleep S4. That's 0.845 volts. Wait a second. That's resistance mode. Whoa. Whoa, you idiot. You dumb fuck. Don't do that. Okay, A, I'm measuring resistance when I want more voltage, and B, I don't even have the fucking thing plugged in. Let's try this again. Let's try this again, dum-dum. All right, we get 0.013 volts. Does that sound like what it's supposed to be to you? No. So, next up on the list, what is going to produce that? Actually, let's just short the power pads for a quick second here. Try to turn it on. And now measure. I forgot this is a Core 2 Duo, and that is not going to show up immediately. It's still not showing up at all. All right. So now we go over to... let's see. Now, at this point, a lot of people are going to say, replace MCP. MCP is bad. It's not shooting out the signal it's supposed to. But this is larger no power issue. So let's go over to page 7 over here. Or 8, because I forgot the page number. And let's go through these rails. Now, what here is going to power the MCP? Ooh, PP1V05 underscore S5 MCP. So send 1.5 volts to the MCP when you're in an S5 state, which is what I should be in right now. Let's take a look at that. Let's take a look. Alright, what do we have here but a tantalum capacitor to ground on output? Now, one of the things you should know here is that electrolytic capacitors have the potential to leak, and tantalum capacitors often have the potential to short. You should always know how these components are likely to fail. So, for example, resistors don't fail by becoming a lower resistance. Most of the time, they fail by becoming a much higher resistance or by blowing or just not conducting properly at all. The way tantalum capacitors usually fail is they start to slowly short circuit. So they don't fail as in they're just not a capacitor anymore. They fail as in they slowly start to leak the power to ground. So if I'm to measure on C7771, what do I get but that's not 1.05, not replacing the MCP. The reason I bring this up is because a lot of people at this point will try to replace the MCP. Even worse, they'll start burning the MCP. And you know what's bad about this? What's bad about it is that when they do that, it'll work again. So they'll say that they fixed it. And the reason it winds up working again is because you heat that little tantalum capacitor up a little bit, and then it stops shorting. So let's see if I can get this one to do it. I probably won't because this machine is 7 years old, so it's probably, and the owner said that every now and then it would turn on and turn off and turn on and turn off. So that capacitor is probably, it's far past its prime. What I'm going to try doing here is I'm just going to heat it up a little bit for you. And let's see if I can get it to work again temporarily just by heating it, just to really drive home that point. Alright, so let's see what I get. I heated the capacitor up. Plug this in. And check that out. 1.097 volts. 1.097 volts. This is, and again, this is why this whole oven thing gets me, gets me enraged and blah. It's because so many of these components can work again temporarily, even when they're clearly destroyed, if you just fucking heat it. Heating is an excellent diagnostic tool, right? When you use it with precision. So, for example, I want to see, is it that capacitor? I can heat it, and if I get a response out of it, then I know that that component is bad and faulty. But heating an entire board, you're not fixing anything, but it's also really not a diagnostic tool. The reason it's not a diagnostic tool is because there's no precision. How do you know what part of the board was actually bad? You have no way of knowing what part of the board is bad because you heated the entire board. So essentially, heating is one of the best ways to, just kind of help diagnose specific faults in specific areas. It's a really good tool in your arsenal, but it's only good if you use it the right way. I encourage using it is to heat a specific area. I'm not saying that you should, but you can heat a specific area and you can heat a capacitor, and because it's heated, it'll work. But do you know what's going to happen 20 minutes later once that capacitor cools down? It's going to go back to its original state, and it's going to short circuit. And the reason that I get all about this whole reheating stuff is because there are so many people that do this knowingly. Like, there are people that genuinely don't know any better. They don't know any better. They think that they actually fixed something. So they're like, okay, great, I fixed something. But then you also have the scam artists that know they didn't fix anything, that offer a 30-day fucking warranty. They offer it, and then when the customer comes back on day 31, they say, man, we told you only had a 30-day warranty on this. We can't help you out, but we could fix it again. We'll just give you 10% off this time because you're a returning customer. And that's a fucking scam. That is a bullshit fucking scam. And professional places have been doing this for years. Which is why I'm against that whole, reflow, oven, blah. I don't really care. People, honestly, if somebody does it in their own home, I know I've said in other videos, you shouldn't. That was bullshit on me. So that was me saying something that was bullshit because I was enraged. But honestly, if somebody wants to heat some shit up in their house so that it lasts again for a week before they get their new one or whatever, I get that. But the reason that this myth is legitimately damaging, the reason this myth is fucked up, is because you have professional individuals that buy into the myth. And once they buy into the myth, they start using this fucking myth and screwing people. And some of them screw people, on purpose because they just think it's cool. They just think it's cool that they get to collect money without having to actually do any work. And some people, some genuinely screw people without even knowing that what they're doing is wrong. But either way, it doesn't matter. You can't screw people. So what I do is, instead of using a tantalum capacitor here, I'm going to use a film capacitor here. It's going to perform it's the same function, except it's not going to have that issue of over time becoming short-circuited and shorting my MCP voltage to ground and leaking my MCP voltage to ground. Because keep in mind, on a buck converter, on the output of it, that capacitor is there to smooth out the output, but it's also there to act like a battery, to store the voltage. And if it's not storing the voltage, then you run into problems. So what I'm going to do here is I made space to fit a larger capacitor in there. So think of this like remodeling. Think of this like not remodeling your living room, right? So I moved the coil up. After I move the coil up, that's going to give me some space to put in a larger capacitor down here. And then I'm going to put this wire down here. I feel bad I touched the end of this coil. As much as it's bad that I touched the casing of the coil, there's a coil inside there, and this is pretty much the armor on the outside. So as bad as that is, it's not the biggest deal because I didn't actually touch the component. But I'm going to do is I move the coil up so that I have room to put a larger size capacitor here that's actually going to work long term. And then I'm going to put a wire here. I'm going to use that wire as kind of my tray, because I don't like scraping the board. You can scrape the board. There are models where you can. This one, there are too many things going on in that area, so I prefer not to. So I'm just going to try to... This is kind of an awkward place to put my iron. So it's kind of hard to arrange this. So I am just going to... lay down a wire. And then I'm going to solder a capacitor in there. SODDER, for all those people who are curious. This is the height of professionalism here. Okay, I'm going to grab myself a film cap. I had a spool of 50 of these. I can't believe I actually ran out. This defect is that common. Okay, and now we're going to put it on here. See what I'm doing here? Got to get my heat and my air up a little bit. This is not the JBC. Okay, now I can see that once I see the solder shooting out from the bottom, I know that I've made some good contact there. Yes, I know this is not the quote-unquote proper size capacitor for this board. But you know what? It's not going to fucking die. That's really all that matters. What would you rather I do? Would you rather I put the capacitor that fits the board? Or would you rather I put the capacitor that's actually going to work and not come back for warranty? The whole thing here, remember, if the consumer comes back for warranty, they're going to have a low, they're going to think, ultimately have less confidence in us fixing this stuff. So I really don't think they're going to open up the machine and look in the bottom of it and see that I fit this there and go, I don't like my MacBook anymore because this guy put a different size fucking capacitor there. But this is the long-term fix. This is the long-term solution. Get rid of the tantalum one over there. Because keep in mind, that capacitor, not only is it's not, the load is not being shared amongst others. It's the only large capacitor on that buck converter on output. Not only is that the case, but it's also the case over here that this rail is always on, S5. Even if the battery is dead, even if the battery has dropped to a voltage that is insufficient for the computer to turn on, that voltage is still sufficient for every other voltage in the machine to be present, including this one. So even if your battery is dead, this is on. If it's plugged in, it's on. If it's not plugged in and the battery is there and it has charge, it's on. This rail is always on for the life of your machine, and there's only one capacitor on output, and it's a fucking tantalum. So again, this is one of those big things with the oven thing. And for all of you people out there who think I'm being paranoid, who think this isn't a scam that people have been doing for a long time, I mean, look up what the warranty repair centers do. So you know when you buy those extended warranties, when you buy extended warranties at Staples or Best Buy or any of those places, the idea there is, the thing is they already have your money. They're not refunding you. So what they do is they send this stuff out to a service center, and all they care about is that they can get it to work. They don't care about customer satisfaction. They don't care about any of that because they already got your money 9 months or 2 years ago. They don't have to care about satisfying you. All they need to do is live up to their end of the agreement, which is just make this thing work again. And if it doesn't work a month later, just send it back and we'll do what we can. And what they do oftentimes to keep the labor cost as low as humanly possible is they will just put the shit in an oven. Because again, what do you think costs more money? Somebody who knows how to find this, or somebody with a $90 Hamilton Beach toaster oven? That being said, what's up? Oh, yeah, sure. Let's do this. We turn it on. Bam. Yeah. You piece of shit. Did you just beep at me? It's beeping at me. All right. No. You don't get to ruin my video. Let's see. Let's try the top RAM slot here. Ugh, old stuff sucks. Beep. Hello. You don't you ruin my video, you motherfucking old piece of shit. All right, we try the different stick and a different slot. Now we get to figure out if it's the RAM stick or the RAM slot. See, you hear that chime? I unplug it, and take this RAM stick, and we're going to try it again in the other slot. It's very common for one of the slots to go bad. One of these RAM slots is usually surface mount, BGA, and the other RAM slot is through hole. The one that's BGA always dies. Okay, so it's the stick. Phew. No dead MCP. Anyway, as you can see, fixed. Bam. And again, the reason that you see this in so many warranty service facilities is that it is cheaper to hire somebody at minimum wage at $6 an hour and have them put the boards into a $30 or $90 oven than it is to pay somebody $20 to $35 an hour to figure out what's wrong with it and use advanced tools to come to the conclusion as to what's wrong. And the warranty service facility, they don't care. They got your money already. They have your money. All they have to do is do the bare minimum required to not get sued. And that is often taking the board and shoving it into an oven, which is what most of these places do. It's a scam. It's bullshit. It makes repair look bad. And this is why I talk about it all the time, because it makes our profession look bad. It screws over customers, and it's something that should just come to an end. That's that for today. And as always, I hope you learned something.